Hello everyone, welcome back. Today we are doing day 2 of chapter 5. We're discussing concurrent lines. So concurrent lines are when 3 or more lines intersect at a single point. This point is called the point of concurrency. So if I have 3 lines that cross at one point, and that last line was bad. So these 3 lines are concurrent lines because they cross at the same point, and that point is called the point of concurrency. A circle containing a triangle whose vertices are on the circle is circumscribed about the triangle. So that means if I have a triangle with a circle going around the outside of the triangle such that it touches all the vertices of that triangle. This circle is circumscribed about this triangle. I'm sorry about my lack of drawing. A circle inscribed in a triangle touches the triangle at exactly one point. So that means that I have a triangle, and inside the triangle, I have a circle so that each side touches the side of the circle or is tangent to the circle. So now I want you to pause, and this is meant to be done. Ignore the groups, and I want you to plot these points and find the midpoint AC, BC, and AB and plot them. Okay, so I plotted the points and then I found the midpoints. So I called the midpoint of AC D, which is at 4, 1. The midpoint of BC is E, which is 8, 2. And the midpoint of AB is F, which is 5, 4. Now we're going to find the slopes. So I want you to find the pause. I want you to find the slope of AC, slope of BC, and the slope of AB. And then I want you to also state the perpendicular slope. Remember, perpendicular slope is the negative reciprocal. So pause and do those calculations. Okay, so you can see that I wrote down the points over here just to help me remember them. Remember, slope is change in y over change in x. So the slope of AC is negative 2/3, which means the perpendicular slope is 3/2. It's the negative reciprocal. The slope of BC is 3, or 3 over 1, and therefore the perpendicular slope is negative 1/3, and the slope of AB is 1/4, and the perpendicular slope is negative 4. So now what we're going to do is it says draw the lines that are perpendicular and pass through the midpoint of each side of the triangle. Using the slope, start at the midpoint and count. So what we're doing is we're finding the perpendicular bisector. So when we want perpendicular to AC, we want a slope of 3/2. So perpendicular to AC is going to go through D, and we want a slope of 3/2. So I'm going to start at D, and I'm going to go up 3, over 2, up 3, over 2. And that is going to give me this purple line here. And that line is the perpendicular bisector of AC. Notice the perpendicular bisector does not necessarily always go through the vertex across. Now I'm going to do the same thing for the other 2 lines. So when I do BC, I'm going to make it a red line. So perpendicular to BC has a slope of negative 1/3, and I want it to go through E. So normally negative 1/3, we would go down 1, right 3, but I really want to head towards the triangle, so I'm going to go up 1, left 3, up 1, left 3. And that produces this red line. Next, I'm going to do the perpendicular bisector of AB through point F. And let's make that one pink. So through F, we want a slope of -4. So we're going to start at F, and we're going to go down 4, right 1, down 4, right 1. And then we're going to draw the pink line. Notice that all 3 of my lines intersect at one point. That point is the point of congruency. So I'm going to call it G. Now, interesting fact when we're doing the perpendicular bisectors. So concurrent, yes. All 3 perpendicular bisectors intersected at a single point. And I don't think it was a point that we can easily tell. Although, perhaps some of my points are just slightly, oh, no, it shouldn't be through there. So, it's definitely that point. Now, a conclusion. This is an important conclusion. Perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant from the vertices. So, if we go back up look at our triangle here that we graphed, point G, if I were to draw, let's make them black so they stand out. If we were to draw the line from B to G, from C to G, and A to G, all 3 of those lines are equidistant. So point G is the point of concurrency such that AG is congruent to BG, is congruent to CG. So anyway, I was forgetting something. This point of concurrency, because it's equidistant from all the vertices, would be the center of my circumscribed circle. So where all the perpendicular bisectors, the sides meet, is a point which is called the circumcenter. And the circumcenter is the center of the circumscribed circle. Because it is equidistant from all the vertices. That's very important that you remember that. Now, example 2. A stove, S, sink, K, and refrigerator, R, are positioned at a kitchen and shown. Find the location of the center of an island workstation so that it's the same distance from all 3 points. So what we're looking for is the circumcenter. And the circumcenter is the point of intersection of the perpendicular bisectors. So what I want to do is I'm going to draw all the lines connecting my kitchen, my sink, to my stove to my refrigerator, and then my sink to my refrigerator. And then I am going to approximate the perpendicular bisectors of 2 of those. I don't necessarily need to do all 3 because I know all 3 are always going to meet at the same point. So if I find where 2 meet, that is the circumcenter, or eye. Triangular shaped garden is shown. Can a fountain be placed in the circumcenter and still be inside the garden? So we know that the circumcenter is where the perpendicular bisectors meet. So I'm again going to approximate my perpendicular bisectors. So I want it to go through the middle and be perpendicular to two of the sides. And it appears that no, it cannot. And why it cannot is because this is an obtuse triangle. So, conclusions. The circumcenter in a right triangle is always on the hypotenuse. In an obtuse triangle, it's outside, and in an acute triangle, it's on the inside. So that's it for today. We talked about the circumcenter, which is the point of concurrency for the perpendicular bisectors. If you have any questions, please bring them to class.